Hi, so in this video, we're going to go over the AP-CSA Unit 2 topic of Boolean expressions, and this is related to the if statements video that we also had on this channel. And speaking of this channel, if you have been enjoying the content and the videos, if you could like this video and subscribe, that would really help us out with getting more people viewing these videos. Let's dive right into the slides. And so Boolean operators are what we're going to talk about. There's three of them that we really care about. An operator means something that we use in an expression to combine two values. Kind of complicated vocab. But 10 plus 10, the plus sign is the operator. So 10 plus 10 evaluates to 20. Okay? 10 minus 7, the operator is the minus sign. 10 minus 7 is 3. And I think I got that math right. So the plus and the plus minus times modulo, which we learned about in a different video, divide. All of those are operators for numbers. What we want to talk about in this video is in Java, we don't just have numbers, right? We also have Booleans. So we want to have the operators that we're going to use to work with Booleans and combine multiple Booleans and evaluate the combination of those multiple Booleans into one Boolean. A lot of words. So let's make it a little bit more concrete. What are the operators that we care about? First of them is the AND operator. So you use the AND operator in Java when you type the ampersand. This little symbol here is called ampersand. It's a good vocab word. And so the AND operator evaluates to true if both sides are true. So you can view this here, and honestly, you just really need to memorize this. You know, this is a new operator that you're learning about. It's probably the first new operator that you've learned about since you learned about what divide is in 4th or 5th grade or 3rd grade. I don't know when people learn about divide. So, it's a new one. So you got to memorize the definition here. But really what you need to know is that both sides of the expression need to be true for an AND to evaluate to true. And this will get logical, especially when we get into the examples. So, here's the definition, but the examples will make it more concrete. The OR operator evaluates to true if either side was true. So what this means, so true or true is true. So that seems a little bit weird because it's like, well, it's not one or the other. Both of them are true, but that evaluates to true. And so what this means is like at least one of the things is true. How about that? So if at least one of the things is true, then it's going to evaluate to true. So at least both are true. So that's at least one means it's true. True or false, at least one of them is true. False or true, at least one of them is true. False or false, 0 of the sides are true, so that's a false. So there you go. So one of the two sides of the expression needs to be true in order for this. At least one of the two. That's maybe the key word. So this slide is slightly misleading. At least one. Because both sides being true is also true. Not is just opposite day. So not true is false. And then this should have a not sign here. Not false is true. So a little mistake in the slides. There should be an exclamation point here. So the exclamation point before a value is the not operator. So a little interesting there. Not means opposite day. Okay. So here's an example, and we can throw this into our code editor over in Pickcode. And so let's just take the code and throw it in there. And let's get our indenting right. And let's make this side a little bit bigger. Let's just see what we've got here. So we've got a person's age, that's 27. We've got an integer, which is the amount of money that they have, which is $120. So if they're, just think about it logically. If they're old enough to buy a car and they have money, then we say that they can legally rent and pay. So both of these things need to be true in order for them to legally rent and pay. And then if a person is, their age is less than 13, so they're like 12, or they're over 18, we can say they're probably not in high school. There are exceptions to this, right? But you're probably not in high school. And we can run this code. And the person is 27, so they're probably not in high school, but they can legally rent and pay for a rental car, which is the example we were using in our if statement unit. You have to be kind of old to rent a car. So there you go. So there's our example there. Now we can change this around. So if we make the person 16, and we say that they have $90, let's see, the opposite, something different should happen here. Let's see. Yeah, nothing got printed out, right? Because they can't rent or pay, and persons aged less than 18, or persons aged less than 13 is false, right? 16 is greater than 13. So this is false over here. And persons aged greater than 18 is also false because 16 is not greater than 18. So both of these are false. So this isn't going to get printed out. And the person's age is not greater than 24 since it's 16. So we already know that this side over here isn't going to get printed out either. So there's a concrete example for you. Okay. So short circuiting is a vocab word. And so I'm not going to read the slide verbatim here, read every single word, but think about it. If you've got an AND operator and you're evaluating both sides, and the first side that you evaluate is false, boom, the whole thing's already false, right? Because we know if either side, if on the left-hand side it's false, we know that the value is going to be false, so Java will skip the second half of the expression. And on OR, if the left-hand side is true, we know that the full value of the expression is going to be true, so Java skips evaluating the right-hand side of the expression. Really minor detail, but it does possibly come up. It's kind of just a cool thing to know about. Okay, there is a thing that is technically on the list of topics in AP Java, and here is a rule for you. It's called, these are called De Morgan's laws. There might be multiple, but this is the one we care about. Not A and B in parentheses is equal to not and or not A or not B. So we could write a truth table for this, but I don't want to. Okay, so a truth table is where you can take every value of true and false and you see what's up. But let's just take this code here. Okay, so let's do it. Okay, let's see. So let's do Boolean A equals true, Boolean B equals true, and then let's system.out.print line this statement here. And what the law means here, what this law is that no matter what I put in for A and B, these two things are always equivalent. So I can put a false here. This is like a mathematical proof, mathematical theorem. So I'm putting in false in both places. I'm just changing these up. Any value of true and false, it doesn't matter what I put in. You can do this all day. Any combination of true and false, you're going to get that not A and B with the parentheses is equivalent to not A or not B. So it's like a mathematical thing that's true. Someone might quiz you on this. It's rare that there's going to be a question on this on the exam, but it is the case. So if you're making flashcards about this unit, this is one of the things you might make a flashcard on. You can memorize it if you'd like. Okay. The final slide on this is actually less about the and or and not operators and more about the equality operators, if equals equals and not equals. And one of the things we need to consider is about comparing primitive values. So int, double, and Boolean are primitive values. The type name is lowercase. And that means that we can compare them with the equals equals or not equals operators. Objects are types like string, or if you make your own class, those are objects, and you will compare them with the dot equals method. So I have a set of good and bad things here. So with strings, you do get dot equals. With strings, you don't do equals equals. With strings, you do dot equals. With strings, you don't do equals equals. With numbers, you do equals equals. With numbers, you don't do dot equals. And with numbers, you can also do the not equal sign. So, oh my gosh, so many nots and so many equals, but that's the gist of it. So basically with numbers, you're going to use the little symbols, and with objects, you're going to use this dot equals method. So that's about it for this video. So we went over a bunch of Boolean expressions and a little bit here about comparing objects, and we're right under 10 minutes. So we're going to cut the video here, and appreciate you watching. Have a good one.